Alright guys, let me get this out of the way. I have RSV, so I'm going to be very stuffy. Forgive me, and I also want to do this video real quick. Basically, I might have found something that may help with overall results. So let me pull up the study. Alright, mind the mess in the background. I'm between projects. But basically, the study, which I'll link in the description, cellular matrix interactions during strain-independent remodeling of stimulated collagen networks. So, what this is saying is they did a bunch of calculus to figure out the model, the rough model of how collagen interacts with its cells. So, the extracellular matrix and the cells that provide, the working tissue of the collagen. Basically, they figured out that the stress is going to obviously be divided up into the collagen network, the ECM, and the cells. And what that means for us, or what that means in general, is that depending on how the stress is applied to the tissues will change how the response happens in the tissues. So you can get a lot of network stress, collagen stress, or you can get a lot of cell stress. And they are always going to try to become equal, but they'll never actually be equal because by design, the collagen is supposed to take the brunt of the weight. So if we look at a normal study, and so while we're looking at these graphs, we're going to get a line at the top, that's the constant, that's the total stress in the model. Then we're going to get a line of network stress. Actually, this is cell stress. So we'll get a line for cell stress, and then we'll get a sign for network stress, so collagen stress. First study, or first model, shows that at about 5% strain, they will eventually achieve an equilibrium where the network is taking up most of the strain, and it will show growth of the collagen fibrils. That's what these big blue lines are. But what really caught my eye is this theoretical one. These are two different models. One, 5% initial cell strain. Very easy for the tissues to overcome. So we have the cell stress slowly coming down and the network stress slowly coming up. Now look how low this is. This is 40 kilopascals. And the other side of the model, with 35% initial cell strain, we are upwards of 350 kilopascals. So 7 times more force is applied. The cell stress immediately spikes and then immediately comes down, while the network stress comes in and handles the brunt of the workload. So there is probably a limit to how much strain the cells itself can take, while this network, the collagen, will continuously take more and more stress. Interesting thing is like, this is the model at 5% strain. This is the model at 35% initial strain. Huge difference in collagen growth. That's what these lines represent. Now, another thing you might notice is how just much thicker they are. Since they're under so much more stress, they will get thicker along in the, because it's basically a rope. The rope itself is going to get thicker to hold more weight. But in general, there's just a lot more cellular activity. And another thing this study pointed out is that collagen will go to the shape it was originally formed in. So you'll get much more length, for example, if we're talking about a tendon length, when it's being constantly pulled at relatively high strains, rather than the thickness. Not to say it won't get thicker, but it's easier to build out when the structure's already that shape. If we can figure out a way to separate cell stress from tissue stress, we can get a lot more collagen buildup that way. The problem is since it is a 1-to-1 ratio, and that was a theoretical model, we can't necessarily do that without tiny ass tweezers and literally pull on the tiny stem cells in our tunicov. easily. So what you need to do instead is relax the collagen fibrils of the Tunica albuginea so much so that way when the stretch actually happens, it shocks the cells at first. So what I'm thinking is you need a bit of heat at the beginning and then a little bit of like Tunica release just to get those collagen fibrils nice and relaxed. Then we want to, where's my demonstration? So this demonstration is YouTube safe, but on my form I will have a not safe for work demonstration of what I am doing. This is going to be a relatively advanced, I'm making sure my mic is picking it up. I'm going to have this is a relatively advanced exercise. So if you have not done PE for over a year, do not do this. So we're going to grip on one side of the shaft, grip on the other side of the shaft, leave about an inch or two gap, probably closer to an inch. Push in. You're obviously going to squeeze together. This is going to cause a relaxation response a bit. And then we're going to immediately pull apart. Hold for 10 to 15 seconds. Relax, move up the shaft, push in, pull out. Push in, pull out. Do that 3 to 4 times. That's one set. Do it 3 times. When I did this, I was at 8 3/4 bone press stretch flaccid before. After, I was 8 and 15/16. It's a hard fraction to say. So, just based off of that, I technically hit my fatigue right now. What I'm also going to do is I'm just going to wear my Apex extender. It doesn't have to be the Apex, it can just be hanging, for like 20 to 30 minutes to like ensure that there's fatigue to the collagen fibril so there's something to build up. Might do some pumping afterwards, but then I'm done. So, in the one time I've done this so far from a good sample size, is I just noticed a lot more activity right away. So like my penis was hotter, thicker, like, you know, more blood in it, and more vascularity. So, not saying this is proven or anything, but there might be something to it. That's why I wanted to bring it to you guys' attention so I can get more data. On the phenomenon, and I can eventually incorporate it into my routines. But since I'm doing so much right now when it comes to like PRP and other methods, I don't know if those results will be isolated. So yeah, I'm going to need some guinea pigs is what I'm saying. So again, I'm going to have a not safe for work demonstration on the forum, gettingbigger.io. I think it's allowed on YouTube, but we'll see. Like the link to the forum. And then let me know what you think on Reddit or on the forum. And I hope this helps you. I hope this is something, because that'd be pretty cool, right? Just imagine if I was able to increase, not I, but we, the collective, we are able to increase our rate of gain by 20% just by doing accordions to it. I'm calling this pulse stretches for now, by the way. I have no idea what to actually call them, because I can almost guarantee you pulse stretches is already taken by something either on Thunder's Place or PE Gym or Matters of Size. So, I do not claim to invent this exercise. I just don't know the name of the original exercise. So, if you guys know what it is, let me know on Reddit. Tell me I stole it. Whatever. I'll talk to you in the next one.